All right, guys, in this lesson, we're going to solve literal equations. And what that means is we're going to solve for a particular variable. Usually students, I'll be honest, they don't like this part because you're not getting m equals 5. You're not getting it equal to a number. So we'll see what we can do, and we'll just work through it. I'll understand that it's not going to be a favorite thing, but when you get to physics and chemistry, it's going to be super duper important that we've practiced this. So that's kind of nice. So I'm going to solve for m. Notice I do have some m's, and then I have some n's. So I need to get things moved one side or the other. And in this case, I'm going to subtract 2m. And this is algebra 2. So I'm going to go ahead and add n at the same time to move everything around. So I have m equals 2n, and look at that, m is all by itself, so we're all set. So, they might look pretty intimidating, but using some solving skills from Algebra 1, it's going to make this really, really easy. I hope. If not, we'll talk until it is easy, okay? I'm going to solve for u, so I want to think about what's going on here. I do see 5u over here, so in this case, I probably do want to distribute. And if I didn't have a u at all there, then I might want to change my mind. At this point, I do want to get all my u's to one side, so I'm going to add 5u. While I'm doing that, I might as well subtract this 6v out of here. Notice I'm going to put it off to the end because this is a w, not a v. That way I don't accidentally get rid of something that I shouldn't. So right now I have 7u, and these guys are gone, equals w minus 6v. Do I have u by itself yet, though? Absolutely not. One more step, we're going to divide it by 7, and then we'll have finally our u by itself. All right, one thing that I want to make sure that I point out for your SAT purposes, however that's going to look here in the future, you might see this as u equals, remember this is 1w, so 1/7 w minus 6/7 v. Okay, so that becomes a complex fraction, so just be mindful that you may have the correct answer. It might look a little bit different, so you might have to do a little bit of translation here and there. All right, let's see what happens here, because this one looks extra fancy. And by fancy, I mean fun, right? I want to get x's together, so here's what I have. I'm going to subtract cx over here, and let's get rid of b while I'm doing it. But here's the problem. ax minus cx, those are unlike terms. So before they were numbers, so they just went together, so that was cool. Now, not so cool, right? All right, so this is where we start talking about it as being an Algebra 2 student. The greatest common factor of ax and cx is x. So we're going to take it out. What's left? A minus c equals d minus b. Now, the next thing to do is we want to get rid of, since we're multiplying here, I don't want to multiply it back. I'd be back to the top step above. I want to divide it out. So divide by a minus c. Divide by a minus c. That takes this whole thing out. So x equals d minus b over a minus c. So it kind of looks like alphabet soup or an alphabet cereal, and numbers and their letters are just going everywhere. Okay, but remember, there's some logic into what you're doing. You want to get everything with an x on the same side. We're going to use it as a GCF. So this is where you become an Algebra 2 student. Everything else, you're going to give that to some Algebra 1 kids, right? But here, now you have a second level of thinking. Now let's see what happens in the next one, because I'm guessing it happens again. Right? Rarely do I give you just one shot at seeing something new. So here we go. We're going to distribute ky plus 3kz equals 4y minus 20. Okay, well that looks terrible, right? I'm trying to get y's together. So anything that has a y, I want to put on one side. So here it goes. I'm going to subtract 4y over here. And while I'm doing that, I'm going to go ahead and subtract this 3kz over to the other side. So here's what I have. Ky minus 4y equals negative 20 minus 3kz. All right, everything that has a y is on the left-hand side. Ky and 4y, they have a GCF of y. So I have k minus 4 left over, right? GCF. And it equals negative 20 minus 3kz. All right, so you got the idea from the last one now is how do we get rid of this binomial? I just divide it out. K minus 4. I might just write y equals instead of rewriting the whole thing. That's either lazy or genius. I'm going with the latter. Okay. Now, as far as rewriting this one, since we have a binomial on the bottom, you probably won't see too much of that as far as written as complex fractions. All right, not too shabby. So that's kind of as bad as it gets, I want to say. So let's take a look at some other ones. I do see some fractions in here, so maybe that gives you a little bit of the heebie-jeebies. We'll just work through it. We're solving for r, so let's get rid of 3s. So 1/2 r equals 1 minus 3s. Right, so technically in Algebra 1, you're always thinking, oh, I want to divide by 1/2. But remember, what you really want to do is multiply it by 2, and that makes the rest of it fall into place. So while I'm doing that, typically we want to have everything simplified. So I'm going to go ahead and make it 2 minus 6s, or negative 6s plus 2. So we have r all by itself. Okay, so we're going to really get into this idea that I want to use that reciprocal to get rid of those. All right, we're solving for f. Remember, I always want to identify what in the world I'm trying to solve for first, see where they are, see what I can do with it. All right, well, let's get this guy over here. Let's add fg. Okay, they are unlike terms, so I'm going to have 2/3 f plus fg. How are we going to move this 5/12 g to the other side? Yeah, we're going to subtract it. Now, typically you can utilize the top and the bottom of the equation just to get things moved around. So it's 1 minus 5/12 g. All right, so now we have this fraction mixed in here, plus we have a GCF, right? So let's go ahead and drag this f out of here. 2/3 plus g equals 1 minus 5/12 g. And we're going to divide by this whole entire binomial on both sides. Now, if I wanted this to look prettier, what I'd have to do is multiply the whole thing by 4, like we have talked about in solving equations. That way I don't have these fractions dragging around. In this case, I might have to multiply by 3 just to get rid of this complex fraction, but we'll deal with that more so later this year. Okay. If we can get through this GCF idea, because that's the new idea, while we're solving for the variable, I'll be super duper happy and proud of you all at the same time. All right, now we should get a problem like this that really sits in your wheelhouse, right? You know what that means? That means it's something that you're comfortable with. I got two fractions set equal to each other, so I'm just going to draw some circles on here, and you're going to like, oh, I get to cross multiply. And you're exactly right. That's exactly what we're going to do. While we're doing this, right, we're Algebra 2 kids now, so we're going to say this is 4x plus 4k. Maybe I didn't want to do that. What am I solving for? I'm solving for x. So let's backtrack. Let's not do that. Right? You know why? Because if I distribute, now it's like doing the hokey pokey, because I have to put it in and take it out. So let's just divide by 4. And let's pick a color, right? So 3/4 j equals x plus k. Should have left a little space here for negative k. So why don't I just do it this way? Right. So it could look like 3/4 j minus k equals x. And those would be the same exact thing. Okay, notice what I did very subtly here is I took the 3j over 4 and turned it into 3/4 of j, because it's the exact same thing, and that's the way you're going to start to see it in this SAT style problem. All right, let's solve for y. I do see a couple of them all over the place, and in this case, at some point, we're going to go ahead and multiply by b. But let's not do that just yet. Let's move the 4, because I want to get this kind of fraction all by itself. And when you see it this way, hopefully that helps. So notice that this is over 1. So now I can cross multiply. so things look a little bit better. So I'm going to have this cross multiplication here. So a minus 3y. Again, the idea is to eliminate fractions to make your life easier. I don't want to do anything just yet until I see how this is going to pan out. What am I solving for? I'm solving for y. Yeah, this time we're going to go ahead and distribute. Why do I think that? Because if I divide by b, I would be back to where I started. Well, I've moved the 4, but it really wouldn't be helpful. So let's get one more line here, minus 3y, and then we'll start to move everything around, right? BA and AB, same thing, plus BY, minus 4B. And remember, all this time in the background, I'm thinking, I'm trying to get y by itself. All right, well, that's not too bad. So that means I want to subtract by to the other side. I'm going to subtract a back over to the right. Again, I'm very reluctant to write it right underneath anything because I know they're unlike terms. I know I did it on the left, but I just, I know those guys have to go together, and I'm thinking GCF when I see this, right? AB minus 4B minus A. And again, we're thinking GCF, so here we're going to take it out because I am solving for y. Y, negative 3 minus B, AB minus 4B minus A, and divide out the whole entire binomial. So get that final answer for y. Now, if you can make it through that, then you're doing pretty stellar, right? Because that's kind of the newer idea combined with fraction and all sorts of stuff going on. And if you're feeling a little shaky, then you're right where you should be. So just stick with it. Hang around for a while. We'll be okay. All right, so that's our literal equations. The next thing I want to review in this lesson, I know it's going to go on for a little bit, so if you have to take a break and come back to it, I completely understand, is we're going to deal with setting up some equations. Sum of two consecutive integers is 37. What are they? Now, we did this in Algebra 1, but we're also going to set it up so you can write equations out of it, because things are going to get a little bit crazy as far as what we ask. Instead of just the sum of two consecutives, we're going to ask for all sorts of different vocab-driven questions about it, so we can logically put them in order. So two consecutive integers. So first of all, I have to remember what an integer is. That's positive, negative, no decimals, no fractions. We want them to be in order, and we want two of them. So we have the first number, x. We have the second number, x plus 1. That's how I get to the next one, right? We want to take the sum of them. So if I add those up, I have 2x plus 1, and it is 37. So that's how we build our equation out of it. So we're going to subtract the 1, 2x, 36. What's half of 36? That's 18, so that means I have 18 and 19. 18 and 19, does that add up to 37? Holy cow, yes! All right, so here's why I can't just rely on maybe some tricks that you thought of in Algebra 1. Two consecutive odd numbers. Okay, so first number is x. The second number, I don't want the next one. I want consecutive odds. So how do I get from 1 to 3? I have to add 2. All right, so this is where it differs just a little bit more. This time, we want 3 times the first one. So 3 times the first one. 3x is 5 more than twice the second. Okay, so twice the second and 5 more. So notice there's no like trick to deal with that. Okay, what are those two odd numbers? So let's go ahead and solve it out. So I got 3x, I got 2x plus 4 plus 5. So that means I got 2x plus 9 equals 3x, and we're going to subtract 2x. So x turns out to be 9. So that means it's 9 and 11 are my two consecutive odd numbers. The really nice thing about this is they told me it has to be an odd number. Is 9 odd? Last I checked, sure is. okay? Then we could plug it back in and make sure everything jives, but I feel pretty confident having set it up that way. So you notice that difference in Algebra 1, maybe you did enough of these that you came up with, oh, I could just take one off and divide it, da-da-da-da. But here, we're really gonna build on that vocab of can you build an equation? So 3 times the first one is 5 more than twice the second. 3 times the first one is 5 more than twice the second. All right, so you see where we're going to go with that. Other thing we're going to deal with still and some more is dealing with these comparison equations. I know this is a tough thing from year to year, but we'll see how it goes. The rectangle has a length that is 2 less than 3 times the width. So I don't know who you had for Algebra 1, but if it was me, I like to highlight that. And the next thing I'll do is I'll go to the end of that. Why is it so important? Because it's a comparison sentence. It compares the length and the width. So automatically right now, the width is x, and the length is 2 less than 3 times that. How do I say 2 less than 3 times it? Well, I do 3x and 2 less than that. If the area of the rectangle is 16, find the dimensions and the perimeter. Okay, so we haven't gotten this far yet this year, so we'll just set it up. Remember, area of a rectangle is the length times the width. So if the area is 16, let's do 3x minus 2 times another x. All right, so here we're going to end up doing some quadratics. So we're really not ready for that part of it yet, but I really do love the setup. So I'm okay with where we got to right here. Remember, this is the important part. Why is the width x? Because it's on the end of the comparison sentence. That's just the way it happens. All right, so let's try it again. One number is 10 more than another. That's x. One number is x plus 10. The sum of twice the smaller plus 3 times the larger. So that means I want to add something together. What do I want to add together? Twice the smaller. 2 smaller plus 3 times the larger is 55. You see how if we can put those into those chunks, it's a whole lot easier to deal with. Right? Twice the smaller sorry if this really slows down for you, but I think it's really important as we deal with equations, plus 3 times the larger with a big plus sign in there. All right, because there's no point in going on and saying, oh, let's just solve it. If you're not sure how we got there, then you're like, I don't really know. It doesn't matter if I get it right after that, because I could never set up another one. So 5x, let's get rid of the 30 while we're working here. 25, so x turned out to be 5. So we'd have 5, and then the other number is 15, which is 10 more than the other number. We knew that was going to happen because we set up our equations that way. All right, so hopefully that gives you a little more insight to some of these word problems. We're going to do some practice here after we check in class, and we'll deal with it from there. All right, so literal equations, remember you're looking for GCF, that's the new thing. And then the second thing was setting up based on those comparisons. All right, way to stick with it. Proud of you already.